Welcome back, Math 7. Today we are finalizing sample space and probability calculation. Today, even though I'm going to set up the, sample space for either situation, but I'm going to show you a little bit of easy way also, which is a little bit of spoiler alert for probability calculation and statistic as you go through in junior high, grade 8 and 9, and then possibly in grade, if I recall, was it 11 or 12? One way or another, it's revisiting. So let's do one of the example that we didn't go through last time, which is available on workbook page 14. Is it? There you go, 14 over here. And after that, I'm going to create some example to go through sample space and then followed by easy way of doing it. I call it mental math method. A question first. A four-sided die, label 1, 2, 3, and 4, and a spinner that has 5 different sections is shown. Create a table to show all possible outcome when the die is rolled and the spinner is spun. And the next example is saying, what is probability of having 3 and swim? What is the probability of odd number and hop? So let's think about our first step first. The question asking about the table. So one of the example I'm going to do table. Another example I'm not going to use a table. I'm going to use something else. Okay. So create a table. We first of all need to understand that the total possible outcome is 4 for the first event. And when it comes to second event, we are going to have, it says 5 areas of 5 different branches. So although it doesn't really matter, you can start with first one, second one, third one, fourth, something like that to show the possibility of die. Oops, I just did a mistake. It says use a table, but you know what? I'm going to use tree diagram for this one, and next one I'm going to use table. Sorry about that, folks. But since you already started that, we can also create the other one. 1, 2, 3, 4, 5. And oh my, I cannot see the whole thing. I think one is walk, which I'm going to use W. Swim, which I think it's S. Glide, I think that's what it is. G. And I have pretty bad hop. H. Last one, I think it says fly, F. So some kind of activity. And you're going to do the same thing. Walk, swim, glide, hop, fly. Walk, swim, glide, high, fly. Walk, swim, glide, high, fly. As you may notice, I have all of those possibilities. That's my A. And I guess this is one of the reasons why the question asks you to do table instead of tree diagram, because as you may see, it's ugly. B. This is where I'm going to teach your skill a little bit. Let's do a traditional way. First of all, the probability. In order to find 3 and swim, it is a good idea to go through the column or row if it's table, or the possible outcome in a certain branch. We have only one possibility, 3 and swim. There's no other condition. So that means the numerator will be 1. The total possibility, you can find it by counting. I have 5, 10, 15, and 20. So 20 situations. So the probability is 1 over 20. Now, before we getting into the percentage, it's a good idea to multiply everything by 5. The reason being is so that we can have 5 over 100. And once that happens, that will make fraction into decimal 0.05. And if you multiply by 100 to find out the percentage, then you will know that the probability is equivalent as 5%. So there's a 5% of chance. Now, I'm going to tell you how we can find total outcome without actually constructing a table or tree diagram. Here's what we do. Event 1 multiplied by event 2. This always gives you the total outcome. What I mean by that is, it really depends on the question though. First event in this situation talk about 4-sided dice. So I have 4 total possibility. Event 2 is a spinner that has 5 different sections. So only thing you need to do is multiply those total possibility. 5 times 4, that is 20. And as you may notice, this 20 is actually correlates to our total possible outcome in these 2 events if those 2 events happen simultaneously. The next one, find out the possibility of odd number and hop. As you may notice, that means I have to now consider every hop possibility an odd number. So that means 1 and hop. That's one situation. 2 and hop, we are not going to pick this one. 3 and hop, yes we do. 4 and hop, we don't put that possibility. So long story short, we have out of 20 possibility, we have 2 possibility. Which means this can be simplified by divided by 2 on both top number and bottom number. Then you have 1 over 10, which is, this is a common fraction that show you the percentage. 0.1, 0.1 is a decimal, thus 10%. This is how we tackle the problem. So, here's what we're going to do. We're going to do 2 more examples, but second example after this, I'm going to do one last example of sample space using a table this time. And then the last example, I'm going to use without the table or tree diagram. That is a little bit of a shortcut. This part, I want you to take out a blank piece of paper. I'm going to put classic example 2. And what I'm going to do, ladies and gentlemen, is I'm going to create So what I mean by that is, alrighty. So let's see. What should I put? I like to put spinner. Let's see. That has 3 sections. And that one, what about we put 11, 12, 13, why not? And we have an arrow that you can rotate. That's a spinner 1. The next example, why don't I do spinner again? Except for this one, why don't I put numbers again in here? But let's do like, well, I don't know, 6, 7, 8, 9. What about that? And you have another arrow, then you can spin things. So imagine you put spinner and spinner 2, you're doing it at the same time. And we're trying to find out the probability of having an even number. B, probability have even number for both. So both even number. This is even number, then odd number. And the last situation is, what about you try to find prime number? These three situations. If we are dealing with multiple type, like I mentioned, tree diagram or table is good method. Let's do table this time. Why don't we try to create a table so that spinner 1 goes vertically, spinner number 2 go horizontally. You have 11, 12, and 13. So we have these choices like that. Spinner number 2, 6, 7, 8, and 9, like that. So if it's traditional way, then we put our outcomes in 13 and 6, 11 and 7, 12 and 7, 13 and 7, 11 and 8, 12 and 8, 13 and 8, 11 and 9, 12 and 9, 13 and 9, something like that. Ladies and gentlemen, know the fact that what you see inside of the table is what we call sample space. It's just a fancy way of saying it is showing every single outcome. So we can use that. And this is little recalling skill. Now, my challenge is there any way you can figure this part out without using the sample space? So that's something that I want to point it out. So obviously, if we go through one by one and then see everything, that's easy part to do. But let's say we are solving this problem without. So if that happens, here's one thing that we do. Step number 1, we estimate. What I mean estimate is estimate, there you go. That means we predict outcomes. And number 2, we can create fraction first. So if I think about A, here's what happened. Let's think about some example of both even number. The probability outcome will be 12 and 6. That's one, right? 12 and 8. That's another one. Because the first spinner, 11 and 13, that's an odd number. So the only thing that is possible to suit this situation is even number 12. And the next one, I have 6 and 8. So you may notice that only, now we can make it into fraction, 2 of the outcomes are favorable. Then how can we find the total possibility? Like I mentioned in previous example, how many total event possibility that is possible? That is not impossible, sorry. How many possible events coming out from spinner number 1? That's 3 events. How many in the second one? 4. So theoretically, 3 times 4, that's 12. And 12 should be at the bottom. Let's double check. So sample space this time is using as a double check. 12 and 6, that satisfy one condition. 12 and 8, that satisfy another condition. And to be fair, that's about it. 7 and 9, those are odd numbers, so I cannot do anything about it. Thus, when it comes to those 2, I express it on the top. And 4, 8, 12, as you can double check in here, 12 is my total possible outcome over here. So it is 2 over 12. Which is technically 1 over 6. And if you perform this calculation using a system tool, which is calculator that you guys have, I am taking it out from the computer. 1 divided by 6 give you 0.16666 is repeating. And if you multiply this by 100%, then you will find that it is 16.7% possibility is what you have, and that's the probability of having even number for both situation. Let's do another one, B. I'm just gonna do the B work over here. P even and odd situation. Imagine again without having this assistant. Let's predict. Even number for the first one, we know that's 12. Odd number, what's my possibility? 12 and 7, that's 1. The next one is 12 and 9. And that's about it. Because like I said, 6 and 8, it is 50 odd, 50 even, 50 odd. When it comes to the next one, 1 out of 3 is even, 2 out of 3 is odd. So long story short, this is the same situation, 2 over 12, which is equivalent as 1 over 6. And that eventually equal to 16.7% possibility. The next one is tricky, prime number. This one seems like you guys already figured most of them out. This time I'm going to go through this example in detail. Prime number. If you look at spinner 1, 11 and 13 are prime number. Prime number definition is you can only divide it by 1 or by itself. So 11 by 11, 13 by 13, something like that. Is there any prime number exists on the spinner number 2? Yes, we have, which is 7. 6, 8, 9 can be divided by some other number like 2 or 3, 2 or 4, 3, something like that. 7 is the only one. So 11 and 7 combination is possible over this area. And 13 and 7, that's over here too. So long story short, this example turned out to be 2 over 12, which is 1 over 6, 16.7%. Same as last time. My last example. This time let's do something else. Let's use some letter instead of number. Class example number 3. Why don't we use spinner again? D, E, F, G. Rotational arrow. That's spinner. But next one, imagine you have a jar and you have some letter in here. Let's say A, C, E, something like that. This time I will not going to create all of sample spaces, but I'm gonna just answer the question. Is there any way that we're gonna have vowels only for both situation? And when it comes to B, why don't I create a question where it says probability that have consonant only without creating the whole sample space? So let's give it a shot. Vowel, that's A-E-I-O-U situation. Right now I can see E and E. So it's a good idea to predict. E and E is one of them. And E and A, it's one of them. If you spin the spinner and if you take one letter out of a jar. So in this case, your numerator is 2. That's the only event that satisfies that condition. However, we need to know the total number. In spinner number 1 event, I have 4 different possibilities, and jar, I have 3. So 4 times, you know what, it's kind of repetitive compared to the other one. Why don't I add something? A, C, D, E. So even though it's not as different, I just add one more, ladies and gentlemen, and it doesn't affect the other one. 4 times 4, that's 16. Sorry, I just wanted to differentiate that situation. Then 2 over 16, I can divide it by 2. Then it becomes 1 over 8, ladies and gentlemen. And what do you know? 1 over 8 is actually a common fraction. If you multiply by 125, you actually have 125 over 1,000, which is 0.125. And if you multiply this by 100, then you will have 12.5%, and that is what we have. So the thing is, we don't need to create any of a sample space. We just need to find out our desirable outcome. Consonant, same thing. D, except we are avoiding E and A's, those kind of A, I, O, U situation. The probability is D and D is 1. D and C is 1. Then the next possibility is F and D, F and C. The next one is D, F, G. G and D, G and C. Did I miss anything over here? D, 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 C, F, D, F, C, G, D, G, C. Avoid anything E or A and E. So there you go. We have 6 predicted outcomes or estimated outcomes that is satisfied out of 16. So if I divide it by 2, then it's 3/8. That is my possibility. Like I said, 3/8 you can multiply by 125 and 125 to make everything into 10, 100, 1,000 so that I can convert it easily. 1,000 at the bottom. 375 is what we have on the top. So you will have 0.375, and if you multiply by 100, then you have 37.5% possibility. And ladies and gentlemen, that is today's lesson. Please look at the homework question that is assigned right after and solve all of those questions.